Hi everyone, today we're going to discuss Unit 3, Lesson 2, the Stratified Random Sample. We have two learning targets for today. We're going to explain how to select a stratified random sample, and then understand how this sampling method can affect the bias and variability of estimates about a population. So today's context: how much do fans love Taylor Swift? Day 1. Taylor Swift and her production team tested a different concert platform by playing a more intimate setlist in a smaller venue and wants to find out how much fans enjoy this new change. Her team will ask fans from 1 to 100, where 100 is the most and 1 is the least, how much did you enjoy the concert? One of the smaller venues has 50 seats, 5 rows by 10 columns, with the stage running along the northern edge, as pictured below. She wants to take a sample of 10 seats. So to complete this activity, you're going to use the Staplet. So go ahead and click that link, either in the email or the subplans folder, and you're going to select to do this activity independently. So you're going to use this Staplet to run through the activity in the notes, generating 3 different samples: a simple random sample, a stratified random sample by row, and a stratified random sample by column. Then when you generate those samples, you are going to reveal the results so that you can compare the 3 methods to choose the best one. So please pause the video now, work through the entire activity. You can work together in your groups if that's helpful, and then we will debrief. All right, so our population here are the 50 people or the 50 fans at the Taylor Swift concert, and the sample is the 10 randomly selected fans from this concert. So using the Staplet, we selected first a simple random sample of 10 fans. So here is my simple random sample. To describe how we obtained this simple random sample, we first label each seat a number 1 through 5. Then we use a random number generator to select 10 unique numbers from 1 to 50. You can also say here that you would select 10 numbers from 1 to 50 with no repeats. And then third, we select the fans in the corresponding seats. So just as a little recap here, to select a simple random sample, we first label, then we randomize, always with no repeats, and then we select. All right, the next method is where we generated a sample that randomly chose 2 fans from each horizontal row. So this is called a stratified random sample. Where our strata are the rows. So we are grouping fans by row. Strata are typically homogeneous. So the individuals in each strata share some common attribute. So in this case, they are all in the same row, so they all share the same proximity to the stage. So to explain the steps here, we first group the fans by row. Then we label each seat in row 1 a number 1 through 10. Then we use a random number generator to select 2 unique numbers from 1 to 10 and select the fans in the corresponding seats. And then we repeat that process for rows 2 through 5. So very similar to our steps for the simple random sample here, we just have to make sure we group the individuals in the population by the strata first. Then we label, Then we randomize, again with no repeats. Then we select, and then we want to make sure we repeat for the remaining groups or strata. For method 3 here, we generated a sample that randomly chose one fan from each vertical column. So this is another example of a stratified random sample. But here our strata are the columns. So these fans all share their distance, right, from the center of the venue. Each column is either on the far end or closer to the middle of the venue. So that's the common attribute that these individuals share in each column. So similar to the previous steps, we group fans by column first, label each seat a number 1 through 5, use a random number generator to select one number from 1 to 5, select the fan in that corresponding seat, and then repeat for all columns. So which method is the best and why? I chose method 2. I think method 2 will be the best because it ensures selecting fans from each row. I believe that fans are more likely to enjoy the show in the front row compared to the back row. So a characteristic here that I believe affects the response to the survey, we're looking at average enjoyment. I believe proximity to the stage will affect the response to that survey question. So typically the best method is the method in which you stratify by a characteristic that you know will affect the response. So typically we choose the strata based on a characteristic that will affect the responses to the survey. So again, here, I believe that proximity to the stage affects average enjoyment. So I want to stratify by row so that my sample contains people from each row, 2 fans from each row. You can see here in my stratified sample by column, I actually didn't randomly select anyone from row 2, and 5 of my fans selected were in row 3. So I did not obtain a sample that ensured or that selected fans from each row. That's why I think method 2 will be the best here. So after revealing the results, you should have seen your sample means for each method, and then it should have revealed the actual true mean enjoyment to be 78.38. So this represents mu here, our population mean. And then once we added 100 samples to each of the 3 dot plots, we can really see the difference between the 3. So all 3 of these methods resulted in low bias because the sampling method did not consistently overestimate or underestimate the true average enjoyment. We had about half of our sample means above and half of our sample means below the true mean in all 3 methods. That's because all 3 were random samples. Typically, when we have a random sample, we have low bias. However, method 2 for me had the lowest variability. So that tells me that method 2 in my case was the best method. So we always want to take a look. We want low bias and low variability in our method here. All right, so taking a look at our important ideas. Remember, our simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. We label, assigning each individual a number. Then we randomize, either using a random number generator or slips of paper. And then we select, making sure there are no repeats. Today we talked about the stratified random sample. This is a sampling method that starts by classifying the population into groups of similar individuals called strata, then choosing a separate simple random sample in each stratum and combining those simple random samples to form the sample as a whole. So each strata have individuals with similar attributes, and we always want to make sure we choose a strata variable as the one with the largest effect on the response variable. So here's just a visual of our stratified random sample. We start with the population. We're classifying our population into groups of similar attributes, our rectangle, our triangle, our circle. Then we take a simple random sample from each strata and combine those simple random samples to form our sample. All right, learning target number 2, a sampling method that produces the best representation of the population has low bias. So this is where that sampling method does not consistently over or underestimate the true population mean or whatever parameter we're looking at, and has low variability. And then finally, the check your understanding. A principal at a large high school is proposing a new digital hall pass that students would access using their phones. She wants to know what proportion of the student body is in favor of the proposed change. She will take a sample of 100 students. So would this sample be with replacement or without replacement? This would be without replacement. The principal would not want to survey the same student twice. So this is similar to our idea of selecting unique numbers or numbers with no repeats. Explain how the principal could take a stratified random sample using grade level as strata. So step 1 would be to group the students by grade level. Step 2 would be to label the 9th graders a number 1 through n. Then use a random number generator to select 25 unique numbers from 1 to n. Select those corresponding 9th graders, and then repeat this for each grade level. So we have our steps here where we group, then label, and then randomize with no repeats, and then select those corresponding individuals, and then repeat for the other strata. And then explain why the stratified random sample might produce a better estimate than a simple random sample. Here we can argue that grade might have an effect on opinion about the hall pass. Maybe 9th graders will support this, where 12th graders might not. So ensuring that we survey students from each grade level will give us better estimates about the truth. And this stratified random sample will give us lower variability in addition to low bias.